M2 just landed, and it's not just another open source model, this is a monster. A 1 million token beast that you can run yourself, no paywalls, no closed-door APIs, no vendor traps. But here's the kicker, it's faster, smarter, and ridiculously cheaper to train than anything we've seen in public AI. You can feed it an entire encyclopedia and still have room to talk. Think DeepSeek? Nah. This thing eats DeepSeek for breakfast. Let's break down why M2 is not just another model drop, it's a declaration of war in the AI space. And yes, you'll want to stick around till the end, because the way they trained this model is insane. Section 1, the shockwave from China. Picture this, you're in a room full of Silicon Valley engineers, investors, and AI fanatics. Suddenly, someone bursts through the door, waving a laptop, shouting, a Chinese team just dropped a 1 million token model, for free. The room falls silent. Eyes widen. Jaws drop. Sounds like a movie, right? Well, it's real. Meet M1, the latest open-source AI model from Chinese research group Miniax, and it's causing seismic tremors across the AI world. M1 isn't just another model with a few fancy upgrades. It's a complete paradigm shift. We're talking about a system with a 1 million token context window. That means M1 can take in the entire Harry Potter series, all 7 books, and still have space left over to generate a reply longer than most scientific dissertations. And this isn't some walled garden corporate tool locked behind a paywall. It's open source, fully accessible, and completely free to use. Why does this matter to you? Because we're witnessing the beginning of a new AI arms race, and the playing field just got leveled. Until now, models with these capabilities were the crown jewels of megacore like OpenAI or Google. They were trained with budgets the size of small nations and buried behind APIs that cost developers a fortune. But M1? It was trained for under $550,000, and it's out in the wild for anyone, yes, even you, to download, deploy, and build on. There's urgency here. Open models like DeepSeek R1 were impressive, sure, but M1 just leapfrogged them, not just on specs but on real-world performance. And that puts pressure on everyone else. The way you use AI in your daily life, your business, your personal projects, it's about to change. This isn't just evolution, it's revolution. So stay with me as we break down exactly what makes M1 such a monster in the AI arena. Trust me, you're not going to want to miss this. Section 2, the 1 million token monster. Let's talk numbers, big numbers. Because M1 didn't just dip a toe into the deep end of large context models, it cannonballed in. A 1 million token context window is a game changer. To put that in perspective, 1 token equals roughly 4 characters of text. So we're talking about a model that can understand, analyze, and respond to entire textbooks, series of legal documents, or encyclopedias, all at once. Let's use a relatable example. Say you're a lawyer. Imagine being able to feed your AI assistant an entire case's documentation, every clause, every precedent, and every footnote, then ask it to draft a motion or summary. It can reference everything. No truncation. No summarizing. No loss of nuance. Or maybe you're in healthcare. You input a patient's full medical history, lab results, clinical notes, and genetic data. Ask M1 to help evaluate treatment plans or generate comprehensive summaries for specialists. Boom, done. Accurately, thoroughly, all in context. Compare this with OpenAI's GPT-4 Turbo, which supports up to 128K tokens. That's just 1/8 of what M1 can handle. Claude 4 Opus? About 200K tokens max. Even Google's latest Gemini 2.5 Pro matches M1 on input, but not on output. It can't reply with 80,000 tokens like M1 can. That output capacity matters when you need thorough, thoughtful responses, not just sound bites. And DeepSeek R1 taps out at 128K tokens in both directions. Impressive for open source, sure, but M1 is on a whole other level. A different league, honestly. This context power fundamentally shifts how we can think about AI applications. Forget chatbots. Think long-form storytelling, research assistants, legal advisors, code auditors, and strategic planners. The kind of assistants you trust with real complexity, not just generating tweets. And it's all made possible through some incredibly clever engineering that fixes one of the oldest problems in AI model design. But before we go into that, just let this sink in. A model this powerful, this contextually aware, and this accessible didn't come from big tech. It came from an open-source lab in China. What does that tell you about the future of AI? The borders are down. The gatekeepers? Shaken. And we're only getting started. Section 3, Beating the Transformer Bottleneck. Okay, so how do you even build a model that can handle 1 million tokens without melting your GPU? Well, this is where Miniax really flexed its genius. To understand their innovation, you first have to understand the problem with traditional transformer architecture. Transformers, the foundation of nearly all large language models, use something called self-attention. In simple terms, every token looks at every other token to figure out what's important. It's like hosting a massive Zoom call where everyone talks at once, chaotic and computationally expensive. As the number of tokens grows, the number of interactions grows exponentially. That's why older models get sluggish or crash if you push their context limits. Even big tech companies can't just scale context infinitely. It's a compute nightmare. Enter lightning attention, Miniax's sleek alternative. Instead of making every token glance at every other token like nosy neighbors, lightning attention organizes attention in a more linear, efficient way. Less chit-chat, more signal. That means the compute cost doesn't explode as input size increases. But they didn't stop there. M1 also uses a mixture of experts, design. Think of it like hiring a group of specialized consultants. The model has 32 expert subnetworks, but it only wakes up the few it needs for a particular task. Instead of brute-forcing all 456 billion parameters, it only uses about 46 billion at any time. That's like having 32 brains, but only calling on the relevant ones when you need them. It saves power, improves performance, and makes the model smarter per watt. Now, let's put that into a metaphor you'll never forget. Old transformers are like trying to cook Thanksgiving dinner with every burner, every oven, every microwave on at once, even if you're just making toast. M1? It uses just the tools it needs. Efficient. Elegant. Game-changing. The payoff? On a 100,000 token response, M1 uses 1/4 the compute of DeepSeek R1. That's not just better, it's a leap into the future. Section 4, Smarter, Cheaper, Faster. Let's talk dollars. Because while M1 might sound like it cost a tech fortune, the reality is jaw-dropping. Miniax trained this 456 billion parameter beast with a budget of just over $530,000. That's not a typo. While OpenAI reportedly dropped upwards of $100 million on GPT-4, and DeepSeek R1 cost between $5 and $6 million, M1 was built on a startup's budget, and still crushed benchmarks. How? Efficiency. Their lightning attention architecture cut floating-point operations, flops, dramatically. And then came a reinforcement learning breakthrough called CISPO, Clipped Importance Sampling Policy Optimization. Okay, don't let the name intimidate you. The concept is powerful. Typical reinforcement learning methods, like PPO, which OpenAI uses, clip gradients for rare, creative responses, essentially silencing innovative thinking. M1 flips the script by capping the importance of tokens instead of muting them altogether. It's like hiring a creative employee, then telling them, hey, don't go too far off script, versus saying, actually, go wild, but we'll just weigh your wildness appropriately. That second method? That's M1. And it works. In real-world tests, this strategy made M1 learn faster, reason more logically, and write more persuasively. It trains quicker, costs less, and still ranks near or at the top on most open benchmarks. If you're a business owner, researcher, or even a solo developer, you should be feeling urgency right now. Because M1 isn't just a tech demo. It's production-ready, cost-effective AI for the masses. And you don't need to sell your startup's soul to use it. Section 5. How M1 was trained to think like a genius. The real genius behind M1 isn't just in its code, it's in its curriculum. Think of it as the private school for AI, tailored to build reasoning, problem-solving, and creativity. Miniax began with 7.5 trillion tokens of pre-training, with a deliberate bias. 70% of the data was STEM, coding, logic puzzles, and hard reasoning content. No fluff. No clickbait. They trained M1 on substance. Then they introduced chain-of-thought supervised fine-tuning, teaching M1 to think out loud, step by step. The result? A model that doesn't just give answers. It shows its work, like your best math teacher ever. But it gets better. The reinforcement learning phase wasn't just slapped on. It followed a human-style learning arc. 1. Start with tasks that have clear right answers, like math problems and programming tasks. These were verified by hard-coded rules or unit tests. 2. Then introduce trickier questions, things with multiple valid responses like science questions or general knowledge. Here, M1 used a generative reward model trained on human-labeled answer comparisons. 3. Finally, open-ended conversations. M1 judged responses using a Swiss tournament-style system, pitting different model answers against each other. This progression let M1 build a foundation, then nuance, then personality. It's not just smart. It's articulate, persuasive, and balanced. Section 6. Cracking the stability problem. High-performance AI often walks a tightrope. Too aggressive, and it crashes. Too cautious, and it underperforms. M1 walked that rope like a pro. Early in training, Miniax found a crucial bug. Model predictions during training didn't match what happened during inference. That's a death sentence for long context accuracy. The fix? Upgrading the model head to 32-bit precision, restoring alignment and stability. Then came the infinite loop problem, a nightmare where models get stuck repeating the same phrase over and over. M1 handled it with a smart stop rule. If the model is generating ultra-confident tokens for too long without new information, it just stops. Simple. Effective. They also adapted the training schedule. Instead of launching the model straight into massive token limits, they gradually increased the reply length, 40K, 48K, 56K, all the way to 80K, checking quality at every stage. This stair-step method meant M1 wasn't just learning to handle size. It was learning to use long context wisely, to avoid bad patterns, and to get smarter with scale. Each step was earned, not assumed. In short, M1 isn't just a marvel of engineering, it's a masterclass in how to train a model to think better, not just bigger. Final thoughts. What happens next? We are entering a new AI arms race. But this time, it's not the billion-dollar labs who have the edge. It's the ones who share. M2 proves that smarter design and clever training can beat brute force spending. And the best part? It's just getting started. So the question is, are you going to watch this revolution from the sidelines? Or are you going to download it, run it, and start building the future? All the links are in the description. And if you want a walkthrough on how to deploy M2 with just a few commands, we've got that coming in the next video. Trust me, you won't want to miss it. Catch you then.